Okay, today we're going to look at Lesson 3, and your I can statement or learning objective is I can factor quadratic expressions. So we're still doing some factoring. We're just moving on to a different type. We're going to factor quadratic expressions. So a quadratic expression is an expression in the form of ax squared plus bx plus c, where a, b, and c are constants, or numbers, and a cannot equal 0. A cannot be 0 because if it is, this term disappears and it's no longer quadratic. An expression is quadratic when the highest exponent is 2. Okay, so the highest is the variable squared. And remember, expressions do not have equal signs and you can't solve them. We are not solving, we are factoring, okay? So, as always, I ask you to write the notes down, try the examples, work along with me, and then use these to help you in Math Excel. And remember, I'll go faster in the video than I would in person, but you have the ability to pause and rewind and watch it at your own pace, okay? Now, with that being said, there's a lot of info coming at you in this lesson today, okay? But I want you to know that I will upload copies of the examples, and you'll see a little graphic organizer that I'm using. I'm going to upload that. I'll upload a blank copy so you can use it if you want to. I'm going to try to give you all the resources you could need to factor quadratic expressions. But like I said, it's a lot of information coming at you. So if you need help or have questions, feel free to hop back in the Google Meet and chat with me or send me an email. Okay, on that note, let's have a reminder of what factoring is. So factoring is breaking up a quantity into smaller pieces. Okay, it's breaking it as low as it can go. So we can take 10 and break it up into 2 times 5 because we know 2 times 5 is 10. We're doing the same thing with a quadratic expression. We're breaking this expression up into 2 smaller parts, and if you multiply x plus 3 times x plus 2, you get x squared plus 5x equals 6. So this is what we're doing. This is what our factoring is going to look like today, and this is what your answers are going to look like. We're practically undoing the double distributive property or the FOIL method or whatever you want to call that. We're taking it apart, okay? Okay, now before we actually start factoring, here's some notes to help you with the signs. Now, don't get hung up on this. This is not where you need to start every problem. And you might not even need to look at this, but if you ever get stuck and you're having trouble with the signs of your factors and you don't know if they should be positive or negative or both, this can help you. If you have a positive b and a positive c, then both of your factors are going to be positive because a positive times a positive is positive, and if you add them together, you also get a positive. If you have a negative b and a positive c, then both factors are going to be negative because negative times a negative is a positive, and those added together will give you a negative. Now, if you have a negative b and negative c or positive b and negative c, then you're going to have a positive factor and a negative factor because a positive times a negative makes a negative. And then the positive and negative b is just going to depend on which factor. Okay, so like I was saying, sorry, I had a little interruption. If you have a negative c, that means one factor is going to be positive and one's going to be negative because a positive times a negative is a negative. And then when you add them together, the positive or negative b depends on the highest middle term that you get when you add. And so you'll see what I mean when we actually do some problems. But like I said, this is just something to help you if you need it. You don't have to use this. You don't have to look at it, but it's there to help you if you do need it. Now, we're going to look at the 3 different ways to factor quadratic expressions. Okay, now we're going to look at the 3 ways to factor a quadratic expression. And I'm going to use this little graphic organizer to help us. I will upload a copy of this finished organizer into Google Classroom so you can have it or print it out if you need to. And I will also upload a blank copy so you can print it out and use it if you'd like. So we're going to use this expression, 3x squared plus 8x plus 5. And first, we're going to look at guess and check. Okay, here are the steps for guess and check. Always, always, always look for a GCF of the expression. Okay, Then you're going to find factors of A and C, and then try different combinations until you find one that works. So for this expression, we have A is 3, B is 8, and C is 5. Okay? And we don't have a GCF. Each of the terms just has an X. 3, 8, and 5, the only GCF is 1, and we don't need to pull that out. So we've identified A, B, and C. Step 1 says find factors of A and C. So my A is 3, so my factors of 3 are 1 and 3, and that front number is positive, so our factors are going to be positive. We don't need to look at the negatives. However, for C, C is 5. Okay, our C is 5. Now, our C could be positive or negative, so we could have 1 and 5 or -1 and -5. Okay, so we're going to make 2 sets of parentheses, and our A only has one option. It's 1 and 3. So we're going to fill in a 1x and a 3x. Okay, then we're going to use our factors of C to fill in the rest. But this is guess and check. So I'm going to switch over to a pencil because I'm probably going to have to do some erasing. Okay, so just to show you how it works, I'm going to try the -5 and -1. So I'm going to say -5 and -1. Okay, I know that x times 3x is 3x squared. And I know that -5 times -1 is 5. So I just need to check for this middle term. So -5 times 3x is -15x. X times -1 is -x. If I add those together, I get -16x. Is that what I should have up there? No. So that doesn't work. I'm going to erase these. I'm going to try again. Let's make it a +5 and a +1. Is that going to help us any more than the other? This gives us a 15x, and this is 1x, and that still gives us 16x. So that still is not very helpful. So what about if I swapped the 1 and the 5? What about if I did 1 here and 5 there? 1 times 3 is 3x. X times 5 is 5x. I add those together and get 8x. Is that what I wanted? Yes. So this is my final answer. X plus 1 times the quantity, 3x plus 5. Now, you could also you could swap it. You could do 3x plus 5 over here and x plus 1 here. As long as you have the correct pieces together in parentheses, it doesn't matter which factor comes first. Next, we're going to factor by grouping. So here are the steps that you can write down. And like I said, you can print out this organizer and fill it in, or you can print out the one that's already done for you. I do recommend that you try it on your own, but it's up to you. For the organizer, you can just do the examples on your own if you would rather. But to factor by grouping, we always look for a GCF. Okay, do that first, no matter what. Then you're going to use an X to keep things organized. So you make an X, and AC goes in the top, B goes in the bottom. Step 2, find factors of AC that add to equal B. Step 3, split up the middle term. And step 4, factor by grouping. Okay, so we're still looking at that same expression that we started with. All right, and again, I'm going to go ahead and say that A is 3, B is 8, C is 5. Okay, I know that I don't have a GCF. We already did that up here, but there's not a GCF. So number 1, use an X to keep things organized. So make an X. In the top, we're going to do A times C. So A times C is 3 times 5, and that's 15. B goes in the bottom, and that's 8. All right, so step number 2 is find factors of AC that add up to equal B. So we need factors of 15 that add to equal 8. So if you think about the factors of 15, we could have 1 and 15, 3 and 5. So a 1 and a 15, is there any way to add or subtract a 1 and a 15 to get 8? No, so that one doesn't work. What about 3 and 5? Yeah, 3 plus 5 is 8. So I'll put a 3 on one side and a 5 in the other. Okay, I'm going to use these to split up the middle term of the expression, so that b term. So we started with 3x squared plus 8x plus 5. Okay, we're going to leave that 3x squared, but we need to split this up. So we're going to change that to 3x plus 5x and bring down the 5. Now we can factor by grouping. So this was just splitting up that middle term. We got the 3 and the 5 over here, from over here. All right, so to factor by grouping, I split it in half. I find the GCF of the first half, which is 3x. So 3x squared, take out the 3x, we're left with x. 3x divided by 3x is 1. All right, on the other side, I pull out the GCF, which is 5. 5x divided by 5 is 1x. 5 divided by 5 is 1. Now, my greatest common factor is x plus 1, and my leftovers are 3x plus 5. And so that's what goes in that second set of parentheses. And again, you see we got the exact same thing as we did before. Okay, you can check your answer by doing x times 3x is 3x squared, x times 5 is 5x, 1 times 3x is 3x, and 1 times 5 is 5. Add those together in the middle, and that does match what we started with. So that is your final answer. Now, before we move on to the last method, let's talk for a bit. Guess and check. Sometimes guess and check is the easiest method, okay? Sometimes it's going to be way more difficult. The larger your numbers are, the more factors they have, the more difficult guess and check is going to be. So sometimes it takes a little bit longer. Okay, but those of you who like a puzzle, you might really like this one because you have to try those different options until you find one that works. Factor by grouping, I think, is the easiest method because, one, we've already learned how to factor by grouping, so you know how to do that part. And it's not too hard to fill in this little x. So I think factor by grouping is the easiest method. But if you have trouble with guess and check or factor by grouping and you want a method that you can follow the exact same steps every single time and get the right answers, this last method, the star method, might be for you. Okay? And even if you like the other two, if you get stuck and you can't figure it out and you just need a method to get you to the right answer, the star method is a great resource. Okay? But you do have to memorize some steps and how to do it. But this can be a fail-safe, okay? It might not always be the easiest or the quickest option, but it is an option that will always work for the quadratic expressions. Okay, so we call this the star method. Again, always look for the GCF, and then step number 1, make the star. You put AC in the top, B in the bottom, and AX on each side. Then you find factors of AC that add to equal B, which is very similar to what we did back in the factor by grouping. Then you simplify the side fractions, and there's a couple notes there. If there's a 1, if you see a 1 on the top or the bottom, leave it alone. Don't do anything to that side. We need that 1 there. And if you have a negative, the negative always stays on the bottom because that's what operation. It's not really a positive or a negative here. It's more of an operation. So don't move that negative to the top. Leave it on the bottom. Then make 2 factors. So again, we're going to say that A is 3, B is 8, and C is 5. Okay? I know that there's not a GCF. That's why I skipped it here. But if you have a GCF, make sure you pull that out first. All right, so make the star. The top is A times C. So 3 times 5 is 15. 8 is B. And we put AX on each side. So 3X and 3X. All right, I need factors of 15 that add to equal 8. So like before, we said we could have 1 and 15 or 3 and 5. And remember, you could have the negatives. Okay, so 3 and 5 is our match, so we're going to put a 3 on one side and a 5 on the other. Okay, so that was step number 2. Step number 3, simplify the side fractions. So I know 3 over 3 simplifies to 1 over 1. 3 over 5 doesn't simplify, so it's just 3 and 5. I'm going to use these two sides to make my factors. So x plus 1 and 3x plus 5. And that's my final answer. Again, you can check your answer. X times 3x is 3x squared. X times 5 is 5x. 1 times 3x is 3x. 1 times 5 is 5. That does make 8x, and so that works. Okay? So that's your fail-safe method. If you're having trouble, you can't figure it out one of the other ways, you can always use this method. Or if you like this method, you can memorize it and use it every single time for your quadratic expressions. Okay, so there are your three methods. Now we're going to move on and do some examples. And I'm not going to do every single method with every single example. I'm going to show you and talk you through which method I think is best for each specific problem. But I will upload the versions of it worked out in different ways on Google Classroom. Okay, for this example, I'm going to use the graphic organizer, and I'm actually going to do this one with each of the methods, just so you can see, because on this one, we do have a greatest common factor. So I want you to see how that works with each of the methods. Okay, so first, we need to notice that we have 15b squared minus 25b minus 10. So the GCF is 5. So I'm going to go ahead and do guess and check. So I have 5, and that leaves me with 3b squared minus 5b minus 2. Okay, so now this is the polynomial that I need to factor. So using guess and check, I need the factors of a. So my a is 3, my b is negative 5, and my c is negative 2. So I need factors of a and factors of c. So my factors of 3 are 1 and 3. My factors of negative 2 are 1 and negative 2, or negative 1 and positive 2. All right, so I'm going to get my two binomials ready. And I only have one option here for my factors of 3, so I'm going to go ahead and say 3b and b. All right, so now I'm just going to try some different options. So I'm going to try plus 1 and minus 2. So 1 times b is 1b. 3b times negative 2 is negative 6b. And that gives me negative 5b. So I just happened to guess that one correct. And I just realized over here, this should say 1 and negative. Oh, I wrote those weird, didn't I? So 1 and 2, 1 and negative 2, or negative 1 and positive 2. Sorry, I was looking at it backwards and realized that it was really correct. So sorry, forgive me. Anyway, so that does work. So there is our answer. Okay. And forgive me again because I almost forgot something. I'm feeling scattered this afternoon, so I do apologize. We have to bring down that GCF. So we have to put that 5 in front of those two factors. Okay, so now we've broken it down to 5, the quantity 3b plus 1, and the quantity b minus 2. All right, moving on to factor by grouping. We still have to factor out the GCF, so we have 5 times the quantity 3b squared minus 5b minus 2. This time I'm going to use the x. And so a is 3, b is negative 5, and c is negative 2. So if I make my x, I'm putting a times c in the top. So a times c, so it's 3 times negative 2 is negative 6. And in the middle, I have negative 5. Okay, so I need factors of negative 6 that add up to give me negative 5. So I could do negative 1 and 6. Negative 6 and 1. I could do negative 2 and 3, or negative 3 and 2. So if I add these together, negative 1 plus 6 is 5, negative 6 plus 1 is negative 5, negative 2 plus 3 is 1, negative 3 plus 2 is negative 1. So the only one that gives me a negative 5 is negative 6 and 1. So I'm going to turn this polynomial. I'm going to just bring down the 3b squared. So 3b squared minus 6b plus 1b minus 2, and I'm going to use factor by grouping. So the GCF of this side is 3b, and that leaves me with b minus 2. All right, the only GCF of these two is a positive 1, and that's times b minus 2. So my GCF now is b minus 2. And then I bring down 3b plus 1. And then I bring down my GCF, which is 5. Okay. And then last, we'll do the star method. So again, we have to bring out that GCF. So we have 5 times the quantity, 3b squared, minus 5b minus 2. Again, A is 3, B is negative 5, and C is negative 2. So I make the star. On the top is A times C. On the bottom is my B, and on the top sides we do 3b. So that's A and your variable. Okay, so very similar to what we did up here, factor by grouping. We need factors of negative 6 that add to give me negative 5. And I know that we did it up here. And so when you broke it down, we found that negative 6 and positive 1 were the two factors. So negative 6, positive 1. 3 over 6 simplifies to 1 over 2. Remember, the negative stays in the bottom. And then 3b over 1. If there's already a 1 there, you leave that side alone. Don't mess with it. So we're going to use this to make our two binomials. We have b minus 2 and 3b plus 1. And we bring down our GCF in front. Okay, so again, you can use all three methods and you can still get the correct answer. Now, we're going to work through some more examples, but I'm not going to do all three methods for each example. I'm going to show you which method I think would be easiest for each one, and then we'll do it that way. Then when you do these problems on your own, you can choose which method you want to use, and it will be up to you. Okay, here's our next example. 3x squared minus 21x minus 15. All right, so I'm going to use factor by grouping on this one. Okay, so I'll come down here. So 3x squared minus 21x minus 15. So for factor by grouping, I need to know A is 3, B is negative 21, and C. Oh, and you know what I did, guys? Forgive me. I forgot to look for a GCF. If we were in person, hopefully you would have caught me and told me that I was doing it wrong. All right, so our GCF is 3, and so that leaves us with x squared minus 7x minus 5. Now, our A is 1, our B is negative 7, and our C is negative 5. Okay, so we make our x, and AC is negative 5. All right, B is negative 7. So we need factors of negative 5 that add to give me negative 7. So I could have negative 1 and 5 or negative 5 and 1. Do either of those equal 7? Negative 1 plus 5 is 4, and negative 5 plus 1 is negative 4. And those are my only options. So neither of those equal 7. So for this one, we would say not factorable past 3 times the quantity, x squared minus 7x minus 5. So this is all you could do. You would have to leave it as just factoring out the GCF. And you might have a problem like that. And if you do, it's okay. All right, w squared plus 17w equals 72. I'm going to use guess and check on this one because it seems pretty easy. I don't have a number in front of w, so I'm just going to go with it. So I don't have a GCF, so I'm going to start with listing my A, B, and C. So A is 1, B is 17, and C is 72. Okay, so factors of A are just 1 and 1. And C, we can do 1 and 72, 2 and 36, and then You can keep going, but we can think of one way to narrow down our options is we need the numbers to add together to get 17. So 1 and 72 can't give us a 17, 2 and 36. 3 is probably not going to help us very much. We can do 72 divided by 4. And so that's going to get us closer. That gives us 4 and 18. So that could give us something closer to 17. Let's see, 5 won't work. 72 divided by 6 is 12. So 6 and 12, that's also close. 7 won't work, but 8, it's 8 and 9. All right. And so look at any of these pairs. Can any of these pairs give us a 17? 8 and 9. So we'll make our binomials, W plus 8 and W plus 9, and then we can check our answer. 8W and 9W does give me 17W. And we know W times W is W squared. 8 times 9 is 72. So this is my final answer. Okay, here's our next example, x squared plus 10x plus 24. Now, on this one, those numbers are pretty small. Everything's positive. It would be really, really easy to guess and check. So guess and check will be your quickest option probably, but just in case, let's say that you're not comfortable with guessing and checking, you don't feel super comfortable with the star method or by grouping, so let's try the star method. So I'm just going to write the problem down here again so you can see it in this box. So we have x squared plus 10x plus 24. So if we do the star method, we need to know that A is 1, B is 10, and C is 24. We make our star. In the top is A times C, which is 24. On the bottom, we have B, which is 10. On the top, we have AX, so that's just 1x and 1x. We need factors of 24 that add to give us 10. Okay, so we can do 1 and 24, or negative 1 and negative 24. We can do 2 and 12, or negative 2 and negative 12. 3 and 8, or negative 3 and negative 8, 4 and 6, or negative 6 and negative 4, and that might be all of them. So do you see a pair that will add together and give us 10? Yeah, 4 and 6. So we put a 4 on one side, a 6 on the other. We already have a 1 with the x, so a 1 over 4 can't simplify, 1 over 6 can't simplify, so we're just going to use these to make our binomials. So we have x plus 4 times the quantity x plus 6. Okay, here's our next example. 6c squared minus 7c plus 2. I think that I'm going to do factoring by grouping for this one. So I don't have a GCF, 6, 7, and 2. The only thing I have in common is a 1, and I can't pull those out. They each don't have a C, so I can't pull a C out. So we're just going to go straight to labeling. A is 6, B is negative 7, and C is 2. Okay, so for factor by grouping, I need this x. 6 times 2 is 12. Negative 7 is in the bottom. I need factors of 12 that will add up to give me negative 7. Oh, so sorry. So 1 and 12, and the negatives of that, 2 and 6, and those negatives, 3 and 4, and those negatives. Okay, which pair could add and give me a negative 7? Okay, these two, so negative 4 and negative 3. All right, so let's split up this middle term into two pieces. So 6c squared minus 4c plus 3c minus 7. Oh, minus 2. Sorry. Guys, I'm struggling this afternoon. Minus 3c minus 2. There we go. So now, split it in half. GCF of this side is 2c. That leaves us with 3c minus 4. The others, or minus 2. Guys, what is wrong with me? If we were, this would be so much better in person because you all would catch my little mistakes and I hopefully wouldn't make as many. So we have 3c minus 2. Over here, our 3 has a negative. Or, oh, that was a plus 2. Guys, I'm losing it this afternoon. All right, anyway, the 3 has a negative, so we need to pull out a -1, and that gives us a 3c minus 2. Our greatest common factor now is 3c minus 2, and our leftovers are 2c minus 1. Okay, this is our last example, and let's do the star method. Okay, so we have -10w minus 129w minus 50. All right, so I'm going to skip all the way down to the bottom of my chart, and I'm going to write the problem down just so we can see it in the box. So -10w minus squared minus 129w minus 50. All right, we do have a GCF. Since this front number is a negative, we definitely have to pull out a negative. And at first I wanted to say that 5 goes into all these, but it doesn't. So we're just going to pull out the negative. And so we're left with 10w squared minus 129w minus 50, or plus 129w plus 50, because we took out that negative. All right, we know A is 10, B is 129, and C is 50. All right, let's make our star. On the top, A times C is 500. B is 129. And on the top sides, I'm going to have 10W. All right, so I need factors of 500. Now, when you're listing out factors of a big number, you don't need to list out every single one. We can use some common sense. 501. Is 501 going to give us 129? No. Neither is 250 times 2. Okay, so I wouldn't use 1 or 2 here. You could write them out, though, if you want to. You could do 1 and 500, 2 and 250. 3 won't work, so what is 500 divided by 4? It's 125. Ooh, now that one looks promising. All right, so 4 and 125. And we've got some fractions to simplify. So 10 over 4 simplifies to 5 over 2. 10 over 125 simplifies to 2 over 25. Okay, and we can use that to make our two binomials. So remember, we've got that GCF, that negative, and we have 5w plus 2 and 2w plus 25. Oh, there you go. All right. Now, I know that this video is longer than usual, and I do apologize for that. I tried to go as quickly as I could, but I don't think that you'll have a video for your next lesson, or if you do, it'll be a very, very short one, okay? So I apologize that it's long, but you needed to see the examples. You needed to see the 3 different methods. Use these examples to do your Math Excel work. Pick a method. You can use the same one every time. You can mix it up and try some different ones, but you are going to need some scratch paper to do your work. You're welcome to print out a copy of the graphic organizer or just use scratch paper, whatever you want to do. But make sure you look at all the resources that I've posted in Google Classroom with this video. They're very, very helpful. If you have questions or need help, I'm here. I'm in the Google Meet. Send me an email. Hit the Ask My Instructor button, whatever you need. But I would be happy to assist you. Have a great rest of the day.